All right, so this video is going to go over pages 16 and 17 in your Unit 2 packet. So we're going to take a look at acceleration notes here. So acceleration is going to be the rate of change in velocity. Okay, in Unit 1, we looked at velocity. Velocity was the rate of change in position, so how quickly were you changing your position over time. And now acceleration is going to be how quickly are we changing our velocity. Now that could be speeding up, slowing down. The point is that you are changing your velocity. Now that is going to be a vector quantity. Okay, so remember a vector is something that has direction. Okay, so acceleration can be positive or negative. Okay, so meaning it can be going forward, backwards. Okay, so if I have like a positive velocity, so let's say my velocity is going this way and it's positive, and your acceleration is this way, meaning negative, that means it's slowing you down. Okay, so when you see a positive or negative, that is an indication of direction. Now, in the next part, it says SI unit is meters per second squared. So you've got to make sure you really understand your units, okay, especially when it comes to reading problems or answering questions on tests. If you don't know what you're looking at or how to write the correct units, you can lose points for that, or you may not even know how to do the question at all. Okay, so things like velocity, that's going to be something like meters per second or kilometers per hour. Those are going to be your most common. Acceleration is going to be meters per second squared. Okay, then you have displacement. That is just distance covered. So that's usually going to be meters or kilometers. And then your time is usually going to be in seconds or hours, minutes. Basically, time shouldn't be the hard one. But you really need to make sure you're looking is if you see meters per second, that's a direct indication that's velocity. Okay, if you see meters per second squared, that's a direct indication that is acceleration. So let's look at our equation. Acceleration is going to be change in velocity over change in time. So we'll elaborate on that a little bit. That would be basically saying your final velocity minus your initial velocity over your final time minus your initial time. Now, usually your time is going to be usually one whole value. We'll just say when it happens. Usually not a final initial. But if we ask for anything change in time where we do give you two different times, you just look for the gap in between those times. So we're going to take a look at number one. For this example, a car traveling 10 meters per second speeds up to 30 meters per second in 5 seconds. What is the acceleration of the car? So this is what I like to do is I like to keep things nice and organized. So I've been kind of explaining this to all my classes is a way to look at these problems. If you're a type of student that when you start reading a word problem and you kind of start losing track of things, you start seeing all these numbers and that panic mode starts to set in and you have no idea what you're doing and you kind of start shutting down. Okay, the first thing I like to do is I just like to label what I have. Okay, or write out what I have. So when I have a car traveling at 10 meters per second, speeds up to 30 meters per second, that means that my V initial was 10 meters per second. My final velocity was 30 meters per second. And they also said my time was 5 seconds. And they're looking for acceleration. It says, what is the acceleration? So A is going to be your question mark. So just something as little as this can actually help kind of like calm you down or kind of organize you into looking at a problem because one, you'll be able to see what variables do you have. Then you'll be able to see what variables are you looking for. And then you can see which equation has the variables that I'm working with. Okay, so, or you can go through a problem, you can just label it. So like you could label 10 VI, 30 could be VF, 5 could be your time, and then A would be your question mark. Okay, whatever kind of helps you. Okay, this is just kind of a way to get started on a problem if you just have a tendency to have an issue getting that ball rolling. So I'm looking for A, and I know acceleration is change in velocity over change in time. Okay, so which is basically VF minus VI over T. So all I got to do is basically plug in. So A is going to be 30 minus 10 over 5. Cool. So that's going to give me 20 over 5, which is going to be an acceleration of 4 meters per second squared. And that was your answer there. So nothing too crazy. It just helps kind of write things out. And then you just kind of plug in and see where it goes from there. So let's go on to the next page. Okay, so now we're going to actually do a little more practice on acceleration and velocity. So remember, velocity is displacement over time. And I gave you the two circle tricks. So remember, if you're looking for something, let's say I'm looking for time and I have acceleration and velocity, I would cover up this time, and that's going to tell me to take my velocity and divide it by acceleration. Okay, so that's how you basically use those little shortcuts. Number one, it says a car starting from 5 meters per second, rolling start, accelerates to 30 meters per second. What is the change in velocity? Okay, so my initial velocity was 5 meters per second. My final velocity was 30 meters per second. I just want to know what my change in velocity is. Okay, so not every problem is going to be some intricate thing where you have all these variables going on. Okay, so you just need to basically write down what you have and look at what you're looking for, and then just kind of go from there. So I'm looking for change in velocity. Well, change in velocity is going to be your final velocity minus your initial velocity. So all I got to do is just plug in, so 30 minus 5. And that's going to give me a change in velocity of 25 meters per second. And there's your answer for number 1. Now, number 2 is going to kind of tag team on number 1. Is if the car from the previous question speeds up to 30 meters per second in 2.5 seconds. So now I have time. Okay, what is the car's acceleration? So A is going to be your question mark. Okay, so I'm looking for acceleration, and I know acceleration is change in velocity over time. Well, I found change in velocity right here. Number 1 was 25, so all I got to do is plug that in. So 25 divided by my time, which is 2.5 seconds. So 25 divided by 2.5 is going to give me an acceleration of 10 meters per second squared. So there's your answer there. Number 3, a car starts going from 30 meters per second to 45 meters per second. So I just gave you velocities there. So VI is going to be 30 meters per second. VF is going to be 45 meters per second. Is accelerating at 4.5 meters per second squared, so I just gave you acceleration. So 4.5 meters per second squared. How much time has elapsed? So T is going to be your question mark. Okay, so I'm going to write out the equation again. So A equals VF minus VI over T. Okay, so the more I write equations out, the more they kind of stick, and you get used to using them more. Okay, so now we're just going to plug in. So acceleration is going to be 4.5 equals VF minus VI, so 45 minus 30 over T. Okay, so this is where you got to be careful. There's 2 things you can do. One, you can go up to this circle right here. If you're looking for T, that's going to tell you to take velocity and divide it by acceleration. Okay, or if anytime you have a variable on bottom, you can just switch those 2, which would be the same thing. It would just be velocity divided by acceleration. So you're going to take that 45 minus 30 and then divide it by 4.5. Okay, so that's going to give us a time of 3.33 seconds. Number 4, Kerry Wood, pitcher for the Chicago Cubs, throws a fastball 101 miles per hour, which is 148 feet per second, whereas Matt Clement only throws 85 miles per hour fastball, which is 125 feet per second. Home plate is 60 feet 6 inches from the pitcher's mound. What is the time difference between Wood's fastball reaching the plate and Clement's reaching the plate? Okay, so I got a lot of things going on here. Okay, 1, I have my displacement. Okay, that's how far it's going, 60 feet 6 inches. Okay, that's going to tell me which velocity to use. Okay, so if I have my displacement in feet, I would rather use a velocity that's already in feet. So that means I'm going to go ahead and get rid of this miles per hour. That's mostly for the sake of you just knowing how fast that is, because baseball does not track in feet per second. Usually it's miles per hour. So we're going to use these velocities right here. And we have our displacement, 60 feet 6 inches, and we're just looking for time. So it didn't mention acceleration at all, so that means we do not need to use an acceleration equation. We're just going to use the V equals D over T. Okay, so what we're going to do is we're going to solve for Kerry Woods first. So Woods, his velocity is 148 feet per second. Your displacement, now this is where you got to be careful, 6 inches is half of a foot, so that's 60.5 feet. And then time is our question mark. Okay, now you do not have to convert to meters per second or kilometers per hour, okay, because your displacement's already in feet, your velocity's in feet, okay, so you just be doing more work than you need to, and we're not asking for it, so don't bother doing it. Okay, so we're going to plug in, so 148 equals 60.5 over T. I'm going to switch those 2 out. So 60.5 divided by 148, that's going to give me a T of 0.41 seconds. So there's your first time. Okay, so there's Kerry Wood's time. Now we're going to do Clement's. So we're going to do Matt's. So we're going to take his velocity, which is 125, equals displacement, which is still 60.5 over T. We're going to switch those 2. So 60.5 divided by 125. And we get a time of 0.48 seconds. So there's both their times. So if you wanted to know the difference, you could just take the gap. Okay, so that would just be 0.07 seconds difference. Okay, but regardless we found the times, so we're good there. Number 5, light from the sun reaches the earth in 8.3 minutes. Okay, so there's your time. The speed of light is 300 million meters per second. Okay, so there's your velocity. How far is the sun from the earth in meters? So that means I'm looking for displacement. Okay, so just simple things like that where you've got to be able to read a problem, know what I'm giving you. Okay, know that when I ask for how far something is, you're looking for displacement. You're not looking for time. You're not looking for velocity. Or if I give you something where I tell you how fast it's going, you got to know that's velocity. Or if I just give you time. So little things like that are going to determine on which equation you use and if you get it right. Okay, so I have my velocity of 300 million meters per second. Now, key why I'm writing this down is because your units are in meters per second. My time is 8.3 minutes. Okay, I cannot just mix seconds and minutes in the same equation because they're not in the same units. So what I'm going to do is I'm going to fix that. I'm just going to multiply it by 60 since there's 60 seconds in a minute. So 8.3 times 60 is going to give me 498 seconds. So now my velocity and my time are both in the same units, and we're looking for displacement. Okay, so we're just going to plug in. So 300 million equals our displacement, we don't know, and our time is 498. Okay, so now we can just multiply both sides by 498, and you are going to get a big number because you got to think about this is the distance from the sun to the earth. Okay, in your calculator, now you can write out all the zeros if you want to, or you may see something like an E in your calculator. That's going to tell you times 10. So if you got 1.49 e to the 11, that's the same thing as saying times 10 to the 11th meters. Okay, so again, you can write out the zeros if you want to, but you still need to be able to recognize the scientific notation, because if we give you a multiple choice question on the test or the quiz and we put our answers in scientific and you don't know how we got to that, then that's going to create kind of a little problem there. Okay, so if it's like a free response, I mean, by all means, write out all the zeros if you want to. It's just a lot of zeros to write. Number 6, a runner accelerates from rest at a rate of 1.25 meters per second squared over a time interval of 8 seconds. What is his final velocity? So key terms here is from rest. That means you started with a velocity of 0 meters per second. So we're not always going to tell you a numerical value. Okay, we can give you in terms like from rest, which means you started at 0, or it comes to stop, which means your final velocity would be 0. Okay, so just watch out for terms like that. Okay, so VF is what we're looking for. That's our question mark. I gave you acceleration, which is 1.25 meters per second squared, and I gave you a time interval of 8 seconds. Okay, so we know A equals VF minus VI over T. Okay, so A is going to be 1.25 equals VF, which you don't know, minus 0 over my time, which is 8. Now, did you have to do the minus 0? No, I'm just showing you how I'm plugging it in, because what if that was different? What if that was like a 2? Then all of a sudden this 0 would be here, and now you have a 2, and now you got to figure out a way to solve for VF. Okay, so I just put that there so you can see how I plugged it in. So it's basically saying 1.25 equals VF over 8. So I'm going to multiply both sides by 8, and you get a final velocity of 10 meters per second. So that'll end this video. So we're going to do a lot more practice in the upcoming videos on a lot of word problems. So if you ever need more help, okay, those videos should help with that practice.